my name is Ilya Konik, my student number is 101460488, and today I will create a video for assignment number 1 with explanation what we have done here. So let's just basically begin with we have some imports, we do load data here, and then we show the shape of this data, so nothing overcomplicated. Then we show length of train and test labels as it was just given to show in our assignment. And also we show first 10 labels here, first 10 labels from test and train labels for data, so we can see here are them, right? And also here we print first we print image number 5 on the index 5 in more computer way, right? In a way of a metric with values of pixel color. Following this, we do use Plotlib library in order to show the image number 5 as well here. And so moving forward, we also want to show the label for it, so it's number 2. In our case, it's pullover, and also we print item number 500 here and do the same. It's also a pullover, however it doesn't really look to me like, but yeah, still it is. And we can see it right here where we print the label for it too. Okay, so moving forward, what we do here is we do normalize the data by dividing it by 255, so we have the pixels values between 0 and 1. Then we flatter the data, and then we create layers of neurons. So the last layer will be basically the output layer of our model, so 10 possible digits in our case. And also here we use activation algorithm of ReLU, and first is 512 neurons, and then 128, right? So moving forward, in part 7a, 8a, we use one type of algorithm. So Adam, as far as I understand, it is more complicated version of gradient descent. And also we strive for accuracy, and we feed the data 10 times, and we can see here that gradually the more we feed data, the accuracy increases, which is good. But following this, we can see that we use another algorithm here, and by plotting each time of epoch, we can see that it actually slightly degrading. So the reason for that will be the overfitting, and also I do output question number 21 here in order to just show here, because it was not really clear which model we need to display, but I think that was for the numbers one, not for the fashion. So yeah, here is the output, and we see that it's slightly degrading each time, so it gets used to the labels and do identify certain patterns more than it should, and this way the accuracy of a model decreases with time. So it also should be considered when we develop models. Following this, we do take a fashion data set, and also we print some shapes of it. Following this, using plotting, right, we plot a couple of items from library with the numbers with MNIST library, right? So in a grid such way, so just randomly some of them. And following this, we use a little bit of magic to compare the labels from fashion, where we can see that the fashion has a more complicated type of images than the first row. And so slightly moving from this, as in question number 19, we needed just to compare. So I think that just to show a couple of labels from here, from there, and to take a look at them. And following this, we will answer question number 20, as I have already answered 21 in previous part. So why the difference in accuracy exists in fashion and in numbers. Even though these two are pictures, we can see that it is easier to reach a greater accuracy on the numbers, as numbers do have certain patterns which are followed, and these patterns are easy to identify, because here we have some boot, we have sneakers, the shape is about the same, and it is really hard for model to pick up and to not overfit with the data. So it's hard to understand what might be sneakers, what might be an ankle boot, or what might be a pullover, what might be a short. Or if we, let's say, run it again and we had better examples, right? So coat or pullover, I have no ideas. It should try to pick up in some layers of our neural networks that maybe, okay, it has some zip line in the middle of a code. So, and this way it's a little bit harder. For example, here code, and this is code. So yeah, it will see some patterns. It would not directly identify these patterns, but the neural network will adjust the parameters so it does understand, but it's still really harder than to pick up on shapes, because yeah, I clearly can identify what 6 and what is 1 and identify some parameters. So okay, might what the neural network pick up, okay, here is the most amount of pixels are here, right? So okay, it might be not actually 6, because 6 has some diversion here less, here more. We never know what the exact parameters what it picks, but that's something close what we might assume the adjustment of our neurons will go for. So thank you for watching, and have a nice day. Goodbye.